Now we're going to talk about the second S in CUSS, which is the shape of the distribution. And so there are a few different ways that we can use to describe it. A symmetric distribution is basically a distribution. This one kind of looks like the top of a castle or something like that. And if you can make a vertical line that would essentially split that right in half, and if you folded it over, would it look exactly the same? We could say that that shape is symmetric. So here's a case of a symmetric distribution. Another case of a symmetric distribution here, kind of curvy. There's like a triangle there. But again, we can draw that and flip it over, and it's a symmetric distribution. And there's a special symmetric distribution that we talk about called the normal curve. And it's kind of hard for me to freeform draw this. I'll give it a shot, but kind of come up like here, and then go down. Not a very good job. I'm going to ditch that. And oh, here's a drawing now. Oh, there's a normal distribution. And we'll talk about more details of that in the next unit, but it's a special kind of symmetric. Now, not all symmetric distributions are normal. Please let me make that clear. Not all symmetric distributions are normal. Okay. Then there's a symmetric distribution called the uniform distribution, where basically every value kind of has the same number of items. This would be that you'd have the same, if we were talking about a test, that the same proportion of people would have 50s and 60s and 70s and 80s and 90s. And so basically every score that there is, the same number of people have that as any other score. Okay, and so sometimes people think, well, it's got to be completely flat at the top to be considered uniform. Here's a case of a distribution that's approximately uniform, and it would be enough so that we would be able to call it uniform without it being like a perfect rectangle, kind of like a Bart Simpson top of the head here. Okay, so there's a symmetric distribution. We also have this thing called skewed distributions or tailed distribution. And so a right skewed distribution, we say it's skewed positively. And so, and again, we call it right-tailed because it kind of tails out. It's got a tail on the right side. And we talked earlier that the mean is less resistant to outliers than the median. So in a symmetric distribution, the mean and the median are right here on kind of the spine. The mean and the median, they're on the symmetric. Mean and median are here at the same point. But when we have a skewed distribution, the outliers pull the mean more than they pull the median. And so on a right-tailed distribution or right-skewed distribution, the mean is greater than the median. And on the left-skewed distribution or left-tailed distribution, it works the same way. The mu gets pulled more than the median, so the mu is less than the median in a left-tailed distribution. Okay. And then bimodal and multimodal. This is bimodal. It just has two peaks that are approximately the same height. And then on a multimodal, you could have three or more. We don't kind of go tri and quad and everything. It's just multimodal, anything more than two peaks. Okay. And then the U in CUSS, the unusual features, I'll just briefly talk about this. The outliers, it's actually a formula. And that formula for a left side or lower outlier is Q1, the left side of a box in a box and whisker chart. Q1 minus 1.5 IQRs, and an IQR is Q3 minus Q1. In other words, the width of the box in a box and whisker plot. So Q1 minus 1.5, Q3 minus Q1. That's a left side outlier. And I'm sorry, I need to change this. And a right side outlier, or upper outlier, is Q3 plus 1.5 IQR, which Q3 plus 1.5 times Q3 minus Q1. Okay. Gaps. Gaps are just if you have a histogram or something, a place where there is no data in a certain area. And then clusters are places where most of the data is, or much of the data is. Here's a cluster in this area here. Okay, and so now we have learned the four components of CUSS: center, unusual features, spread, and shape.